Hello, Michael.
Yes, Eddie.
Okay. Yeah, I was about to ask about the recording or the live stream, but I think you've started it, so it's okay.
Okay.
Thank you. Okay. So to just do a recap, I'm not sharing the screen yet. I'm just speaking very soon. I'll share the screen. To do the recap, Michael, please, can you allow me to share screen? It's disabled. Yeah. So on Tuesday, we had a good discussion on the cloud computing power of the Digital Earth Africa platform. I think that they were able to register. Then we went through some of the existing notebooks that are already existing on the platform. That if you don't even have any knowledge in Python coding, you would be able to work with it by changing the latitude and the longitude for that particular area. So today, as part of today's training, we are going to actually do a hands-on training on how to build from scratch on the cloud computing. So let me share my screen. So before I actually move on to the onto the platform for us to start working, I just want us to do a few soft writing for some of the areas that you would like to actually look at. Before you even start doing the coding, some of the things you have to be prepared before you get into the coding aspect. That's to generate your workflow. So you're going to look at the generation of the workflow and how you can generate that. And if you're able to get the workflow right, it will actually make it easier for you when you start coding, because you follow the workflow step by step to be able to generate whatever notebook that you want to do when working on a cloud computing, and especially using the Digital Earth Africa sandbox for that particular work. So not to get much in time, let's jump into it, and I'm going to start it from the PowerPoint presentation. So there's going to be a little bit of writing. Then after that, whatever you're going to write here, you will translate that into the notebook to actually get the job out of it. So the first most important thing is the objective. What do you actually want to achieve? What do you want to make analysis out of the Earth observation data set that is actually available? So we need to know our objective. So I just put the title here initially. So the objective of this work that we are going to do is to get a time series analysis for a study area using NDVI. So you want to actually get the NDVI time. So let's do this with the NDVI time series for a study area. So the NDVI time series analysis for a study area. So that's going to be the main objective. So having this main objective in your hands, then from this stage, that's where you're going to actually break it into various steps. I'm not going to use the flow chart. I'll just be using the bullet points. So you're going to use the bullet point as a flow chart just for it to guide us on the work that we are going to do. So this is our main objective. What we really want to do is going to do the NDVI time series analysis for a study area. So the next thing is we are talking about the time series analysis. So time series, that means you should have a beginning and an ending time for a particular period. So which period are you actually interested? Then you're going to, so for this one, you'll be interested in 10 years span. So you'll be interested in 2012 to 2022. Let's pick it up. So I'm interested in this time, 10 years time spans period. And the next question that comes to mind is, within the days, so like we have the daily, we have the monthly. So we have the daily, and the daily can be computed to get the monthly, either the mean, or you can even get the quarterly or semi-annual or the annual. So which one are you actually after? Are you interested in the annual NDVI time series for a particular area, or are you after the quarterly one or the semi-annual? So based on the study period, we will go for the monthly time series analysis. So you also have to specify that. So the monthly. So that means you are going to look for that. So what we are actually after, we are looking for a monthly NDVI time series analysis for a particular, for any study area that we are going to choose. Perfect. Then the next step that will come up, okay, so which data set is actually available for us to use that one? So because the data let is actually built within the data cube format, all the data sets that we have is in the data cube. So you have to inspect and see which of the data set you would want to use. Okay, so let me share. So that means you have to go to their data catalog, the Digital Health Africa data catalog, to see what type of data they have. So let me pick this one. Let me share this. Okay. So as you come here, we have about 65 products available currently on the system, including the Landsat and the center, a lot of data sets on it. So we are dealing with NDVI time series analysis. We have to inspect the data set that we would like to use. So from here, you can actually look through all the data sets, and there are a lot of them available that you can actually pick up and use depending on the one that you are interested. But for these tutorials, I'll be interested to use the geomedian, the monthly geomedian. So you have so the surface reflectance monthly geomedian. You have to you actually look into this. This is what we wanted to use. So let's see the time period for that particular data set that we have. For this particular data set, it's actually a Sentinel-2 geomedian, and as you can see, it's from 2019 to 2023. So if I want to do it for 2012 to 2022, this particular data set won't actually help me. But because of these tutorials and because I want to use this particular product, I will change the time span of mine. And as you can see, start from January 2019 up to June 2023. So I'll just change the time span to so that we stick with the one from Sentinel. So the product that I'll be using, let's go back to the PowerPoint. So the product that I'll be using will be the S2 the geomedian Sentinel-2 geomag. So one might ask, what is this geomedian all about it? One good thing is all these data sets that we have the documentation for it. So if you go to docs, which I'll put it in the chat. If you go to the docs section of Digital Health Africa, you actually see all the detailed information about all the products that we are just talking about it. So as you can see we have the GeoMad Cloud-Free Composite. By clicking on the GeoMad Cloud-Free Composite, it will give you the detailed explanation of how this GeoMad actually works and how it is being computed from Sentinel-2 and Landsat. So it gives you that general idea about it by looking at the doc section for this particular area. So right now that we've gotten our we've gotten our the period, we've gotten the hello. Hello.
Hi, we lost you briefly.
Oh,
And your
okay.
screen has stopped sharing.
Yes, Mike. Okay. So let me bring it back. Okay. So right now, after getting all the data set and the metadata information that you need, the next step that you want to do is how do you want to proceed within the notebooks? All those things has to be listed just as a form of a guide to help you to know how you are going to build it up and follow it. Let me shift it here. Okay. So now we are going to go to the notebooks. So within the notebook, what do we actually want to do? Remember, Python deals with packages, and packages makes it easier for you to work with the data sets that we have by not doing a lot of coding. So you just call the package, then you work with it. So with the time series analysis that you want to do, what are the steps or what are the things that we need to do? The first thing that we need to do is to import the packages. So what are the packages that you will need? So this is where another section of the digital evidence actually comes in. We have the package sessions. So we have the normal Python packages, so such as the NumPy, the pandas. So you have the NumPy, the pandas, the GeoPandas, yeah, and so and matplotlib. Matplotlib library. So all these packages are very important because the data set is built in the form of an X array. And to be able to communicate with X array, these packages are very, 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 very important. Then after that, what would you also know? So NumPy will help us in calculation, the same as the pandas. GeoPandas is another version, is the geographical version of pandas. Matplotlib will help us to do the plotting of the data sets. But aside that, because we are dealing with the open data cube, they also have their own packages that we would like to work with. So those one also has to be in mind. So such as data cube. You also have the defined area that will help us to define our area. So these are some of the packages that you'll be using. For more details about most of the packages, for more details about most of the packages, if you visit the docs page that I sent to you, let me share the screen. Where is the screen share? Yeah. If you visit, yeah. So if you visit this particular area that I shared with you, and you scroll down, you actually see that you have the DE Africa 2 packages. If you click on more, to let you know the packages that the Digital Africa actually have and how you can actually implement those packages within your work. So it's always good to check these tools day in and day out. New tools are being added to it, and it also will make your work more efficient. So it's always good to check these ones out. Another way also to check the tools available is to check the existing tools that we have on the existing notebooks that we have on the platform. They come with a lot of tools. So if you want to see how a particular tool works that is of interest, kindly check some of the packages that we have, and you'll be able to see. A minute, please. My screen is lost. Okay, yes, it's back. Kindly check some of the tools that you have, then you'll be able to see some of the packages that is available. If you can't go through the doc session, looking through the notebooks will actually gives you an idea of how some of the notebooks actually operate. So after doing the plotting, okay, so let me go to the plot. So after defining these things, the next step is to load the data sets and define our parameters that we've listed there. Then you will plot some of the images out. Then you will calculate the NDVI from the S2 geomap. Then you plot the results. Then you export the image. You export the image. So you have these steps, and these are what you are going to follow to actually help us to be able to develop our system. So there's going to be a lot of back and forth here just to follow the guidelines to be able to get it. With this, you can actually develop a nice flow chart whereby you use diagrams and the flowchart image or flowchart images just to proceed it forward. So these are something that you have to actually do, prepare it, put it on paper, anything, and after that, once you go onto the programming side, it will make it quite easier for you, especially if you want to do just follow the steps, then you'll be able to work it out. So right now that you've done this, let's go straight into the notebook for us to start working. Okay. So please, before we start the coding, any question? If no question.
So, Eddie.
Hello, Kamna.
Yeah, I'm seeing one of the packages being a Jupyter Hub or something. You made mention of the NumPy, Matplotlib, and the rest, but I'm seeing Jupyter Hub as also part of the packages. Has it also got anything to do with what you are going to do?
Oh, okay. So it depends on what you'll be doing. So if you will need Jupyter Hub along there, you will import it inside. So what I just listed was some of the examples of the packages that you will be using.
Okay.
Yes.
Thank you very much.
No problem. Okay. So now let's move on to into the notebook. Then you will be able to start the coding. So the first thing that you will be doing is to create a folder by clicking on this nice icon here. So you click on it and the name will come. Then you can give it any name that you want to give. So you can give it Day9 Geospatial. So let me just bring it. What name should I even give to it? Okay, let me just give it JGS, just a folder. So let me just give a name of JGS to it, JGS. Perfect. So now that you have the JGS in, you open this particular folder. Then within the folder, you right click. No, we shouldn't right click. Please click on this plus sign here. When you click on this plus sign here, and this page will come. Because you are after Python, you're going to click the Python tray under the notebook. I'm going to click the Python tray. So as you can see, a new notebook will be developed. A new notebook will actually pop up here for you, and we can actually name it. So let's name it time series. So I want to name it time series analysis. Okay. So it's always good for Markdown. Okay, so now let's go to the notebook. And before we start, let me close some of these pages. There are a lot of pages that has been open. Go to the kernel, shut this one now, shut this one now. I want to free a lot of space. So let me shut these notebooks down so that I get a lot of space to get a lot of time. So before you go into it, I just want to take you through the notebook. So this is actually the notebook area. This is the save button. This plus here is adding additional cells. So this is what you term as the cell, what I've selected, adding additional cell. This is cut. And this is copy. If you want to copy a particular cell, this is paste. If you want to execute a cell, you usually use this button. If you want to stop executing, if you want to restart the kernel, that's the instance, you use this one. Restart the kernel and rerun the whole notebooks. And you also have the cell type. So you have the code, you have the markdown, and you have the raw. So let me just explain one of how the code works. So with code, when you type something like 2 + 2 and you click on execute, it will run and give you the answer. But if you change it to a markdown is actually in the form of a test. That means you don't want that particular cell to be executed. So if you run, you're just going to get the 2 + 2 as it is there, just as it is. So what you normally do with the markdown is it's actually form part. It actually gives you a text format for you to express what this particular notebook does or what a particular cell does. So for instance, if I want to name or title this notebook, I can actually use the markdown for it. And there are a lot of formatting options for the markdown. So for instance, I can just simply name NDVI time series analysis. So I can write it there. It's going to be fine. If I want to format it, to be bold, I just bring the stars there, then it will be formatted as bold. What else can we do? There are a lot of formatting that you can actually do with this. This is actually called the note. Actually, if you want to do a note, you can actually do that formatting there. What else? There's the other formatting also that we can do with it. Suppose you want to make it header. You can use the hashtag, just bring a space between it, then it will be larger. If you want to make it bold and a little bit larger, if you actually want to make it big, you use one hash key, and it will be very big. So if you the number of times you are increasing the hash key, the header sizes will be changing. So that's what actually the markdown actually does. And the raw, as the name is going to be just like raw, just there. It won't be executed, but like you're going to see it in the form of the cell, and you're going to see the same thing there. So at this point, I'd like all of you to create the notebook and also just create an NDVI time series as a markdown as this. Then we will continue. So I'm going to give you about 3 minutes for you to do this. Then we continue. I'll be right back. Okay. I hope by now everybody has been able to create the folder and also created the notebook and name it as time and as series .pid. And also I've been able to create the NDVI as a time series. The title, NDVI time series analysis. So let me just make it very nice. Yeah, that everybody can see. So the next thing is, before you actually work with any Python packages, what you have to do is to import all the necessary documents that you need, all the necessary package that you need. If you don't import those packages, it will be very difficult for your users, for you to be able to work with it. So the next thing is to load the packages that you need. And normally, let me chip it, it's always good to comment your cells, not just that it will be easy for someone to understand, but for you, the one who is also coding, because there are a lot of things that you are doing. Sometimes you can just write a script, then someone asks you a question, then you come back, then you forgot what that script was doing. And it can actually it will take you about a minute or two for you to remember that, oh, okay, this is happening. So it's always a good idea to just write a comment first, because before you want to do, you know what you wanted to do. So please, it's always good to add a comment. And within the code, the best way to add a comment is always to start with the hash key, then you put a comment there. So loading of packages. So you're going to load the packages. And you can always, if you know all the packages that you load, you can always move around, copy a notebook and bring the packages inside, and just take the ones that you don't like out and just keep the ones that you like in. So I just copied it from another cell and I pasted it here. So the ones that I don't like, I'll just take them out. So the first thing that you do is we brought the magic key here. That's matplotlib inline. It will help us to visualize our maps. If you want to visualize the results, the matplotlib inline help us to visualize it. Then the first one was the importation of the data cube, which is very, very important. Then the next one was importation of the X array, XR. I hope when you had the previous training, the team actually took you through, if you see something like as SR, what it actually means. So within the code, we don't want to call the full name X array. We just want to call XR. So it serves as a guide name. When I call XR, I'll know that I'm talking about X array. Then we have our GeoPandas also available. Then we have our matplotlib.pyplot, which is going to be used for visualization. It's very, very, very important. They have the geometry package, which we will need when we want to define the area of interest. The data handling, load ARD. Actually, we are not going to use the load ARD here, so I'll just take it off. Visualization, RGB, is very, very, very important. If you want to visualize 3 bands, like 3 bands colors in the RGB format, is very, very important. The calculate indices package is also very crucial, because instead of us to go with formulas, like you have to, what's the formula for NDVI? What's the formula for EVI? What's the formula for MNDWI? What's the formula? All those formula packages, what are they? The calculate index comes with all those formulas. So all that you have to do is, if you want to calculate NDVI, you just call the calculate indices, then the rest will follow up for you. You don't actually have to worry yourself about it. So that's why we've actually imported the calculate underscore indices function. And also, we also have the define area. So these are going to be the packages, the basics ones that you will need. If along the way, whilst we are coding, a package would become important, I will just call that package at the where we've reached. So we don't necessarily have to come and run everything from the beginning. If I have to do that, I'll do that. Yeah, I just forgot one package, which I have to bring it back. There's one package that I forgot. Remember, when the list that we defined, we made mention of exporting our final results as a GeoTable. And that one also, there's a package for it. So we have to bring that package, which I'll bring it here. I'll also put it here. Yes, so that's a package here. So the datacube.ut.com, this file called package will help us to be able to export our data set as a GeoTIFF so that we can actually work with it. I just remember this. So let me go back to the checklist and see that the thing that I said I wanted to do, if I've actually gathered all the packages that I need. So the packages, so I wanted to import NumPy pandas. Once I have GeoPandas, it's okay. I can ignore NumPy pandas. I've imported the XArray. I've imported the matplotlib, define area, and also some other things.
Eddie, can you send them the import statement so that if they don't have it, they can easily get it to continue?
Okay. Okay. Let me put it in the chat. Okay, perfect. So I've put it in the chat, so you can just copy everything and paste it within the cell area. Okay, so now we need to create another cell. So you click on this addition, then that cell will be created. So the next cell, what you want to do is you have to create the DataCube instance, which is very, very important. So let me comment. Create a DataCube instance. So normally it goes by this. This is equal to DataCube into bracket app is equal to. So you give it a name. So I just say NDVI underscore time series. Perfect. So the next step is always instantiate your DataCube. Always instantiate your DataCube. Because this is a cell by cell code that you are doing, any cell that you develop, you write something there. It's always good for us to execute it, because if there's a mistake, you actually identify it as soon as possible. So what I'll do is I'll just click on this. See that it's reading, then it will change to a number, meaning it's working. Let's assume you made a mistake. So let me take the last one. Instead of import define underscore AI, you just wrote import define underscore AI. You didn't add a EA to it. And let's see what happens if I execute it. Okay. Normally, Python can give you a lot of scripts, a lot of information where the problem is. But the most important thing is always check the last sentence. That's the important to give you an idea where the problem is. So you say cannot import name define AI from the DE Africa tools area of interest. What is telling you that we don't have any package called any function called define underscore area. So anytime there's an error, please read the last sentence. It will let you know where the error is before you come back and trace where it actually is. So once you come back to trace, you know, okay, this is where I made the mistake. So just telling that I cannot import DE Africa define underscore AI. Once I tell that, then you move to you run through the code, then you actually say, okay, this is where the error is coming from. Then you choose it, then you make that correction. So once you make that correction, please rerun the cell again. Another thing is, if for instance, this cell, what I've just highlighted, depends on the cell above. If you don't run it, you are going to get an error. Let me just restart the kernel. Try now, restart the kernel. Let me go restart the kernel and clear all outputs. So when I've done it, remember, DataCube depends on the cell above. So if I don't execute this one and I run it, let's see what will happen. It will tell us name DataCube is not defined. But the question is, haven't we defined it? We've defined it here, but why is it telling us it's not defined? Because we haven't executed it. So Python always run from upwards to downwards. I've forgotten the keyword. If I remember, I'll tell you. Python is a. I know it was mentioned to you. The keyword for that. Interpreter language, meaning it doesn't compile. It runs step by step. It doesn't compile all and identify the error for you. It runs cell by cell. So what you see, just telling us the data cube is not defined. That means we have to actually come and run this particular cell. Once we run it, it will be executed. And now if you run the next cell, let's see what will happen. Perfect. Right now, you don't have any problem with that cell. So please be mindful of those who are errors. And the data cube, if you spell it wrongly also, let's see what will happen. Say the modulo data cube has no attribute data cube. So just telling you. So then you go back to where the error is. So you just point to the error is at this side. You just go back there, then you go and make the necessary correction. Perfect. Now, we have now instantiated our data cube. The next thing that you are supposed to do is to define our area of interest. So I just went to copy a code from there and brought it back here. So to define our area of interest, if you have shapefile, that would have been nice, but I don't think we have shapefile. I don't have the shapefile. So I'll just pick any area of interest that I know. Then I'll use that to be able to get the latitude, the latitude and longitude for the study area that I would want to work with. So I'm using a particular study area, but the latitude and the longitude can actually change it from the area that you want to work with. You can change it from the area that you want to work with here. So at this point, we are just specifying a latitude and the longitude for the area that you want to work with. Then I'll click on run. So when I change to number, meaning everything that you are doing is actually correct here. But I wanted to find out the area that I'm working with. Please let a minute. So I've actually brought up this area up here, but the question is, I've just specified latitude and longitude of a particular place, but the latitude and longitude that are specified, does it actually falls on where I want to see, or it falls at a different region? With that, we have to actually look at it, and that brings up another package that we didn't import. That's the display image, the display. We didn't import that one at the beginning, so it will be good if we bring it and come and import it into the image so that we'll be able to see what we are working with. So we know that the area that we are working with, we have an idea from it. So for this one, I'm going to be from. It's always good to add it to the package of the Bible because you are doing it cell by cell. You go with that. So from the Africa _ tools.plotting, import display map. So you need a display map to be able to display the map here. So I don't want to go back and run everything, but because you're doing it cell by cell, you make sure that you put it there, then you run it up. So having it here, we display the latitude and the longitude. So we're going to type the display map. So the lat long, it accepts lat long and the long. One might ask, we are dealing with all these packages, but how do I know how each packages work? The notebook actually makes it quite easier for us. So if you want to understand how this display maps work, just click on it, right click, and choose. Okay, so what you do is just click on that particular item, then right click, then go show contextual help. Just click on that. Contextual help will actually bring all the information that this particular package, you need to run this particular package. So as you can see, it talks about the display map into bracket. It accepts the X and Y, the coordinates, the default, the margin, and the bias. So if you want to work with it, just pick it up and work with it. So that's actually help us know the lat range and the long range. So all the packages that we have there, if you want to get those information on how it works, just right click here and go to the show contextual help. So from here, I can run it. Then I will display the area data. So as you can see, I've actually gotten the area of interest that I would like to work with. Okay, so please, any question up to this point? Any question?
Yeah, we are following it, but I don't know. The code, because if we say we want to type, it's going to take our time. So we aren't able to follow some of the things. So I don't know if you can share it on the listen for us to copy so that we can then follow line by line or something. I don't know. Because I was trying to type them, but it appears it's not going to work that way for me for now, because you're also using it to explain the steps.
Yeah. Please check the chat. I've put the codes there.
All right. Thank you very much.
Yeah, please, the codes are there. Okay. So let me put the new one that I put here so that you can continue. Okay. So the next step is to load the image. The next step is to load the image. So we have to create a variable that will save our image for us. So you're going to call it ndvi underscore dataset. And we'll be using the DC load to load our images, the DC load. So you're going to have the DC. Remember, we defined the DC load at the top here. So this variable actually now holds this instance for us. So anytime you want to call this instance, you're actually going to call the DC load here. So once you call the DC, then you add the load to it. So the DC load actually also comes with parameters. So for it to help us, let's right click here and go to the show contextual help. So the contextual. So as you can see, there are a lot of information here. So the things that you actually need for the DC load is first one is the product. And based on our information, the product that we wanted to use was the rolling geomat. So let me go back to the Explorer. Let me switch to the Explorer. Then let me go and check the code. So these are the codes that we normally use it to call the product within the sandbox. So for the rolling geomat, this is the code. So JM_S2_rolling. So I'll copy that. Then I'll come back to the data. Then I'll open like this. I have to put it in the string because it's a name. So I have to put it in the string. Then the next thing that you wanted is you can look through, you notice that you have put a none here. That means if you don't even bring it, the system won't throw an error. So is it that you provide none or you don't provide a none? Then the next step that you are going to do is the measurement. So the measurement is another name for the measurement is the bands. And the bands works in the form of a list. So NDVI normally use the red. I'm going to call the visible colors first. So the red, the green, and the red, green, and blue. You can call them anyhow. But NDVI actually is the near infrared, so I'll call the NIR also attached to it. The question is, how do I know these bands? Come to the Explorer, click on the JM_S2_rolling, or you can even go to the docs section, the one I showed previously, to get more information about it. If you scroll down, you're actually going to see the measurements here. So the main measurements for it is actually showed here. So as you can see, these are the measurements. So I'm going to put the near infrared. Then what else? What else? Let me check my Excel sheet. Okay. So the time period we wanted is the time period is always in the form of a loop, tuple. So from start year to end year. So I wanted 2019 to 2022. The product is a monthly product, so you are going to get it monthly. But because you're doing a time series analysis, let me just go back small. Let's use only 2019. When you finish or you add the 2022 to it. Anytime you want to do something, always best to start small. Then once the code works and everything works, then you enlarge it to for it to take more data sets into it. But because you are doing this, you are just going to stick with 2019. If everything works, then you come and add a 2022 to it. Remember, we are dealing with internet, and you just want to make sure that all our data sets are working. So you bring that, then you bring the comma. Then the next thing that you will do is the area. We have to specify the area of interest. We have to specify the area. We have to specify our X and Y. We have to specify our X and Y. So so that's our X and Y here. Then the resolution. So the X is here. And the Y is here. Then the next thing is the resolution that you want to work with. The resolution that you want to work with is also in a form of a tuple. Let's make it, shall I go 10 by 10? Okay, 10 by 10 will be fine. Or I can go by 20 by 20. Or I can even decide to go 100 by 100, depending on what I would like to use. Then the next thing is the output underscore CRS. So ESP, EPSJ, EPSJ 6933. I'm using the meters one. Okay. So I think these are okay. These are okay. Let's try and run and see if you will be able to see whether it will come. If you don't get any error, hooray, that means our code works perfectly. If you get an error, we have to look into it. So the code works. Let me copy the code and let me put it in the chat so that I can also have it at your end. Perfect. So right now the code works, and we can actually inspect the code by copying the variable and pasting it in another cell and clicking the play button. So as you can see, let's go into the variable and explain some of the things for you. But before that, please, if you don't bring comma, make sure that every parameter within the function load has a comma before the next parameter. Otherwise, you're going to get an error. Now let's move on to the parameters. So the time dimension, what you see here are a series of image that has been built in the form of an X array. So it's the normal satellite image that you see, but it's actually built in the form of an X array, which makes it very easier to work with. So 12 images were returned, and the number of pixels along the y-axis is 220, and the number of pixels along the x-axis is 194. So those are the pixels that are available. So you see we have the red band, the green band, the blue band, and the near infrared band. The bands that you don't need, because you didn't call them, they will not come. So if you need any band, so if you need a shortwave infrared band, or you need the red edge band, you need the SDV bands, please do call them so that they will load up for you. If you don't call, the ones that you call are the ones that are going to respond. And all this one actually makes it easier to optimize your data sets and make them work very fast. So if you are working with them, it's to be very fast for you to do that. The data loaded, the data is now loaded up. So our data is now loaded up. But wouldn't it be good if you were able to visualize some of the data? Yes, there's actually 12 period, so you'll be able to visualize it. So let's visualize it. So I'm going to do RGB. Remember, we imported the RGB band. If you want to know more, right click on the show contextual help, then the RGB will come. So the RGB bands, it takes in the form of a data set, as you can see here. The default band is red, green, and blue. So if you load it, it's going to pick the red, green, and blue for you. And the rest is how you want to work with it. So our data set is called NDVI data set, which is here, comma. Then the next thing that you do, what do you actually want to do? Let me go back to the contextual help just for it to guide me. We have the index here. So the index is what image do you want to display? Remember, we have 12 images here. So if I type index is equal to 0, it will display the first image for you. Computer programming language, 0 is considered as a number. So although you can see that it's counted as, you can see that it's 12 here, that's counting it. So because 0 is considered as a number, it's part of the 12. But if you are calling it, you have to call it 0. And the last number is going to be 11. So the last number is going to be, so please, although you are seeing 12 here, the first image doesn't start from 1, it starts from 0. So what you want to do is you want to visualize the first image. So you click on it, voila, you have been able to visualize the first image. If you want to do subsets and do visualization, you can put them in a form of a list. So I want to visualize the first image. If you want to visualize a pole, you go to 4. Want to visualize, you go to 6. Then you go to 9, and you click on that, then you run it. Voila, you're going to get all the images for the 4 different months. But suppose I want to visualize all the 12 images. Is there a way to do that? Yes, there's a way to do that using the call. So use the column equal to the specify the time. You close it, then you run it. Once you run it, it's going to take some time, but it will just come. And you can even play with the size. You can even play with the size here. So these are the images. If you can't see them, or you can actually play with the size. So let's do the call wrap. You want 2 images at a time, and you want the size to be 10. Oh, 10 is big, right? Okay, let's try 10. If it's big, then let's try it. If you don't remember, just go to the contextual help and to give you all this information. So the call wrap is 4. That's why you see every row you see 4 images, and the sizes is 6. But then I want to increase it to 12. So now you click on it. Then you wait for it to just run out. Okay, perfect. So as you can see, now we have all these images available for us to use. So let me copy it and let me paste. Please, any question before I continue? Okay, so as you can see, the notebook is actually taking shape. So let's do a recap. The first thing is we actually loaded the packages that we need. Then the second thing is we actually instantiated the data cube and stored it in the variable called DC. The next step was to create the latitude and the longitude for the study area, which we've created it here. We forgot that you have to display the map. So I have to, along the way, bring the display map within the system. Then the map was displayed. Then we did the NDVI data set, created the NDVI data set variable, and we loaded the rolling geomat onto the data set, as you can see right now here. We specify the latitude and the longitude, the resolution, and also the information. Then we display the results, that 12 images were returned with the red, green, blue, and near infrared band. Then we just display the red, green, blue bands just to appreciate the image that we are working with. Okay, so the next step is, now that you see that everything is okay, can visualize, the next thing is to calculate the NDVI. Calculate the NDVI for the study area. Calculate the NDVI for the study area. So this is how you're going to calculate the NDVI, and it's going to be please pay attention to him. Remember, when we were collecting the image, we only had the red, green, blue, and near infrared. So right now I want to do the NDVI. So let's do that. DS underscore, what variable did we use? We use the NDVI, so it's the NDVI underscore data sets. So you call this variable, then equal to, remember you call something that calculates indices is up there. So if you click on it, let me pull out this one so it becomes very big. If you right click and go to the contextual help, it will let you know that the calculate indices accept the DS variable. So you're going to put this DS variable here. Then the next thing is the satellite missions. We have to let the system know the satellite. Sorry. The next thing is to talk about the index that you want to work with. So we are dealing with NDVI. So you type the index, you type the NDVI. NDVI. If you check the contextual app and you come down, you actually see that there are a lot of bands here that you can actually work with. So if it's CVI that you want to work with, you call EVI. Sorry, all in caps, you call EVI. But with this one, you're working with only NDVI. So you call the NDVI here. Then we have the satellite mission. So the satellite mission is the satellite that we're going to do this computation on. I forgot the satellite mission name. So let's go through the, so it said DS is an X array data set. Index is a string or list of strings. So we have one string, because you're dealing with NDVI, we are dealing with, yeah, so we can, even it's a string, so I can decide to do this without putting it in a list. Then the next thing is just to look at the satellite mission. So if you look at the satellite mission, is C2, that's C2. If it is Landsat, is LS. If it is Sentinel, it's S2. Yeah, so that's, yeah, so LS and Sentinel, S2. So because you're using Sentinel, you're going to go with S2. Then you close the bracket. There is something here. If you put drop is equal to false, please don't do that. Always make sure that you don't put drop is equal to true. Otherwise, the red, green, blue, and the near infrared bands that you have previously, all of them will be deleted. Then it will left only the Sentinel-2 imagery. So right now that I've put all this information there, let's try and see what happens. Oh, it's done. So right now let's display the NDVI data set and see what happened now. So if you look at the NDVI data set, you normally see that NDVI is now what? Attached to it. So previously, we only loaded the red, green, blue, and near infrared. They were not there. NDVI was not part of it. But if you run the calculate indices that which we just ran, if you run it, you notice that right now NDVI is part of what? It's part of the indices. So if you have an indices in mind, all that is important is load the correct bands, then call the calculate indices on the data set, then everything will be calculated for you on the fly without even thinking about the formulas. And we have a lot of formulas there which you can use for it. Okay. So now we want to plot our NDVI to see how the NDVI will actually come out. So I can actually do NDVI. So I'll call the data sets. So how do I call the NDVI? So one of the things that you can do is you bring a square bracket, then you call the data inside, you close it. So if I do NDVI underscore data set dot, it will call the NDVI for me. If I do it dot, if I want to call the red band, all I do is call the data set, then within the square bracket, I put the band name there. It will call that particular band for me. So right now I'm only getting the red bands for those areas. So if I need a near infrared, I just call the near infrared within the band, then I'll have it here. So this is just how XRA, NumPy, Panda, this is how they work. They deal with columns. So if you want to call the data set for a particular column, just do call it and everything will be listed for you. But right now you're interested in the NDVI. So I'll put the NDVI here, then the NDVI will come up. We want to plot the NDVI results. So how would we do that? So if I do the plots, what chart something funny will come. With this one, you can't use the RGB data set. So this one, you have to use the matplotlib function to plot it. So okay, then why don't I use dot plot and let's see what happens. You get an histogram. What are you using this histogram for? We are interested in that. Back container. This is not what you're interested in. You want to actually spatially plot it and also plot the time series analysis for this particular image. So how do we do the spatial plotting? Okay, let me do this. Let me bring something called time here. It's equal to time. And let's see what will happen. Perfect. So let's increase the size. Let's increase the size. The size should be 8. Let's do call underscore wrap. color should be equal to 2. Then let's give it a nice color. So you're going to use CMap from the Matplotlib library. Let's use RDYL, red, yellow, green. So let's do. All these are inbuilt packages color for Matplotlib, which if you Google, you can find different colors for it. So you plot this. I just want to increase the size, then I'll do the core wrap for all of us to see the results. Okay, so as you can see, this is the NDVI range and the color is very, very big, right? But let's copy it and put in a tab and let's see how it will shape. Okay. So you see the color bar from red to green and blue to green. As it shown? Hey. Very big, right? So it start from 20 so you can now see it starting from February all the way to 2020 January. So this is the NDVI. So this is a spatial plotting for one particular year. But you also want to see the time series, how the time series actually would work. Okay, so how the time series will also work for the year. So you also want to do the plotting of the graph. You also want to do the plotting of the graph so that you actually see how that is also done. So the plot of the graph is very simple. We will call the NDVI and as data set. Then you call the NDVI out. Then you do something that's mean because you want to see the average monthly. You want to compress all this image into one figure. You're going to use the mean. Then you tell where you want it to be the along the X and Y axis. You tell him to do it along the X and Y axis. Then you plot it. So this will give us the time series analysis for this particular plantation field that we have. You can increase the size. The size works with this guy. Okay, size works with him. You can give it marker. Maybe if you want the marker, so you can specify the marker. You can use M. Yeah, M is fine. Oh, sorry. Yeah, is it markers? Yeah, markers. So you can see for each particular time. Or you can actually use the simple shortcut. If I use the RO, let me use R. That means I want the color to be red. I want the line to be dash line, and I want the, oh, sorry. Position arguments follow keyword. Oh, okay, you want position arguments. Oh, sorry, so this one should have come here. See we're given. No problem. And now let me just use the ones that I know works. Then C should be equal to red. Now what again? I forgot the line. C is equal to red. Then, okay, so if you forget, just go to conceptual at the conceptual test. Welcome. Okay, don't worry. So once you click on that, it will give you the time series analysis and the NDVI values. You can actually make it nicer by giving it a title. So let's give this one a title, PLT title. So NDVI, title should be in a string. NDVI time. Yeah. Close it. Then you run it and you see your title showing there. So PLT.show. I want this particular text to be off. Once I click on it, voila, then I get it. I'll get it here. So when I'll be able to get a time series analysis for the study area that you are dealing with, you'll be able to plot the graph, although you haven't styled it, but you can style it, you can format it. Let's label the X as it. So plt.x label. X label should be, let's put it month. Oh, PLT. So it's a name ply is not defined. Ply. Then it points out to where you want. So it's PLT. By the time I might ask, where are you getting this PLT from? Remember, from the beginning, when you did the importation, we said import matplotlib as PLT. So that means anytime you call the PLT, we are talking about the graph that we are importing. Let me put this one in the chat so all of you can have it. Perfect. Now that we've had this, the next step is get our objective. Sometimes we may prefer to have our work with the PNG. It's very easy for us to extract them, which we did the other time. But sometimes we might want the objective and maybe style it more, give it a more garnished thing. So how do you actually import the objective? So that's where the objective actually comes in. That's where the objective actually comes in. So this is how you are going to do it. You're going to write, remember, we imported a package inside called write_call. That's the package that you're going to use to export it. The write_call actually export one image at a time. It actually exports one image at a time. So write_call, and I'll bring the bracket open. Let's see the parameters. So I'll go to the contextual help for write_call. So it takes the geometry. So we're going to do the NDVI. What's the name? NDVI_data set. That's the data set that you're after. And what it does is it exports one band at a time. So you're going to do, you have to specify the band that you want. So the NDVI. Then you close it. Then you have to specify the band. So you know, we have 12 images. So you have to specify the image that you want to download. So for this, you only download the first image. So I'm going to do it. So with this, I'm going to use the iCell time is equal to 0. So that's what I want to do. Then the next thing was, let me check the next information that you need here will be the F name. How do you want to save it? So that's going to be NDVI_1. Then kindly add the .tiff to it. Then you can overwrite it if you want. In case it's already there, you can overwrite it. You can overwrite it. So once you have this, then we run the data sets. Perfect. If you check into a database, let's refresh this side. You see the GeoTIFF here. So you can download the GeoTIFF and send it into the ArcGIS or whatever you want to do. One might ask, what about if I have more than one images? For instance, you already have 12 images here. How do I get all of them out? All you have to write a for loop. A for loop can do it for you. You know that the image that you are giving it is 12 images. You can write for I in range 12. The action to so for here, can just make here I can put I here. And when you run it, and mind you, you also have to change the name so that they don't overwrite each other. So you can put the I here. So once I click on, let's go. So let me just make it 0.12. Yeah, so start from 0.12. Then let's execute it. If I execute it, let's see what happened in my dashboard. You get all the images there. If you want to export it based on date, that can also be done. You can also get it over there. So this is a hands-on training on how to actually develop a simple time series analysis notebook, which actually encompasses all the things. The rest is making it a little bit complicated, adding certain things to it. But all of the notebooks that we do, we normally follow all the steps that we just followed it up to be able to get your results. So this is where I will end. And right now, any questions from you?
Hello.
Hello.
Yes, the buffer. What is the minimum you can enter?
So it depends on the RAM size that you are using and the area and the number of measurements that you want to load. So for instance, if you choose the buffer of 5, the buffer is actually works in the form of a degree. So one degree is approximately 111 kilometers. So if you choose like 555 kilometers, and it all will boil down to your measurements. You can actually make it big, but all will come down to how you'll be able to manipulate your data sets so that it won't use much of your memory. But as it stands, I think you can go as far as 5 or yeah, you can do that.
No, I mean as low as you use 0.02 or so.
Yeah, I use 0.02. Yeah.
Yes. Okay.
So you can go
so
to
I can go as low as 0.001 or something.
Yeah, I think 0. Let me check. Let me check 1 meter. I want to check 1 meter right now. So if 1 degree is equal to yeah, I think you can go as low as 0.1. That would be better. So 0.1 is okay. 0.01, sorry.
Okay, thank you.
Thank you,
And
Gloria.
yeah, and also the previous day, that was Tuesday.
Yes.
About the shapefile, I tried using a shapefile, but it didn't work. It gave me an error message.
Oh, really? Oh, okay.
Yes, I sent you a message, a private message on it, but it seems you couldn't.
Oh, okay, Gloria. Sorry. Oh, okay. Okay, sorry for that.
I don't know if you have a shapefile that you can try it out.
Yeah, let me see if I can get one now. So you can try it, yes, yeah, right now.
Yeah, yeah.
Yeah, we should try. Let
Okay, I wanted to ask a question, but maybe let's try the shapefile thing.
Okay, let me just see if I can get a farmland somewhere around here. Where is my downloads? Downloads. Farm.
But Doc, let me find out from you the shapefile that you used. What was the SRS, the special reference system of that shapefile? Did you check the special reference system?
I'm referring to Dr. Gloria, me.
I'm asking Dr. Gloria, the one who said he used the shapefile and never worked. Because sometimes maybe if it's in Imperial and you're also using metric or something, or if the reference system is also not correct, it may throw you somewhere and then give you an error or something. So I don't know.
Oh, okay.
Yeah.
I didn't, because the last time he explained it simply as just loading
Yeah.
it. Uh-huh.
And that is it. That
So I
exercise.
uploaded it and it appeared in the notebook, but it told me it couldn't define the I have to get the error message.
Okay. Okay. All right. So maybe it could be the CRS.
Oh, okay.
Of the shapefile, yeah.
Okay, so if it's in decimal, degree decimal, because what
then that
he
means
has
that. So if it's in degree decimal, that means it's likely to be lat long, and therefore you must check ESPG number for WGS84 or something else, so that it can conform to your coordinate system.
Okay, but please, have you tried using uploading a shapefile?
In fact, yesterday I was looking for my shapefile in the WGS84. I couldn't find it, so I stopped. I know maybe it will work. I couldn't find. Some students sent me a shapefile, which I was looking for it on my system. I tried, I couldn't find it, but I'll try it and maybe get back to you. Yeah, right.
Okay, thank you, Kabna.
You're welcome, sir.
So let me check. I think I uploaded something here. Okay. I have uploaded something, but I don't know how big this data, but don't worry. So what you do is you first take this guy off, then you comment this guy in.
Yes.
Then let me check. Let me copy this guy. Oh, sorry. So this was east underscore 9. Okay, so we can run it from here.
Okay, so yours is a GeoJSON. Okay, yeah, you see an error message.
You can actually bring in a shapefile, but I just get last week I made mention of either JJSON or a shapefile.
Yeah.
I just managed to get this JJSON actually makes it easier because shapefile I have to make sure that I get all the
5 or 6.
Yeah. That's one thing about the okay. So this one, Jumio. Check something. Oh, okay. This is series of points. Okay, this one won't help. It is points, so I need polygon. Let me go and search for a polygon. Because it threw me off. Although it uploaded, but it threw me off to a different place.
Yes. But do you need to define the file path as it appears on your local drive?
No. So as you can see, when I uploaded the document here,
yes,
the Y is, let me say that to come back again. Okay, let me upload it. Where is a minute? Documents are you? Okay, okay. Okay, let me open this guy. Okay, so okay, so please can you see my screen now? So when I uploaded this, I have the mode of JJC here, and it's
Okay.
at this place where the notebook is. So all that I have to do is I'll just change this one to the file, to the name. So mode.jjc. And if I run it, it will upload the area for me. So you don't actually have to just pinpoint it to the area that you want to work with.
So is this okay? No, so the location is showing here. Okay, this is, and then this one,
This one
are they the
shows
same
us a
location?
different. Yeah, so when they are the same.
Okay.
Yeah, so this is the National Mole Park.
Yeah.
It has actually taken here. So we can continue from here. Let me try and load only 1 month so that we see the outcome. Because I think it's very big. Okay, so it's done. So 2 times step return. Now let's plot it to see. Okay, so whilst it's loading, okay, so this is for the area that we just loaded. Very dry. And I think from here, then the NDVI value won't be great.
Mhm.
Actually, a very dry place. For
Yeah.
between
Okay.
February and March, that's for Molly. That's the JJC I got.
Okay.
Okay. So please, any other question? Once we wait for it to load.
Please, after this session, is it possible to contact you
Yes,
for further assistance?
that would be great. I'll be available. Please, I will. Because you already have my contact, please, you can reach out to me.
Okay.
Please kindly say hi again, because yesterday I wasn't in the. Actually, I didn't check.
I
So maybe
understand.
yes, please. So please.
Okay.
Okay. So this is just for 2 months, and we see the NDVI value. Not that much impressive, but it's okay.
Yeah.
Okay, so that it will also be downloaded, and you can get the GeoTIFF and work with it in QGIS or GIS file.
And do you have a question?
Yes, Michael.
No, this is Kwabena.
Kwabena, sorry. Okay.
Yeah, in one of the codes where you started from the RGB. Because
Yes.
I'm not getting it because I was thinking it should be assigned to a certain variable or something. I don't know. But that one starts right from RGB to bracket and the NDVI data set, column, time, wrap.
Yes. Okay.
Yeah.
Okay. So the RGB
Yeah,
function.
this one. Yes.
So the RGB function automatically picks the red, green, and blue bands from the data set
Okay.
and it out for you. So within your measurements, if you specify the if you specify the red, green, and blue bands, and you call the RGB function, let me right click here for you to see. If you go to the contextual help, so this is the RGB function.
Okay.
Pick the data set, then automatically the default bands are red, green, and blue. Unless you want to change the default bands. If you want to change the default bands, then you have to bring it in. So like, for instance, if I want to change one to NDVI, what are these bands is equal to command. Then I'll do the red. I'm just playing green and maybe NIR. Unless you want to change it. But if you don't change it, automatically the system will know that you are dealing with the red, green, and blue near infrared bands. Then once you click on it, it will plot it for you.
Okay. Okay. I think I got it now.
Okay.
Thank you very much.
No worries, Kavna, anytime. Okay. So this will bring us to the end of the introduction to the cloud computing power. There are a lot of things that we can actually do with this platform. It makes your work easier, even if you have to leave it for it to run for some time, and you don't need the internet, you can just put it on and go. So I think, hello, Mary.
Yeah, please, my question is, this one, we worked with the NDVI and then it was good. But then when you are calculating any other index apart from the NDVI, will this code still stand? And then my second question about the resolution. When you started, you wanted to type in 10 by 10. And then you change to 20 by 20. Will it affect the buffer zoom if the resolution changes?
Okay, so so let me start with the first one. That's the bands. So the calculate indices actually helps you to get access to a lot of indices within the platform, not only NDVI. So one of the things, if you right click and go to the contextual help. So this is a calculate index function. Let me just put it here and let me collapse this. So as you can see, there are a lot of indices available. So all that you have to do is, if you want to work, the one that you want to work with, you just type it here, LAI, then it will come up for you. Aside the calculate indices, we also have the Spendex index. This is also available on the platform, which when you import, you also get access to over 200 indices that are on the platform that you can also use to work with. So although I use NDVI, you can also use EVI, or if you can do computation of both, NDVI, and EVI. The system will automatically on the fly is going to calculate all of it for you. Okay, so the resolution, you can actually change the resolution. I was just contemplating either to use 20 or to use 10, just contemplating. But the buffer, it doesn't affect the buffer. But all that it will do is, for instance, if the pixel size is 10 by 10, so the buffer will be fixed. But if there are 40 pixels within, okay, so let me do an example so that all of us will understand. So right now, there is 20 by 20. If you look at the X and the Y, let me use the old one so that you'll be able to load fast. So right now you're using the 0.02 buffer zone for this particular area. So I want us to experiment this. If I change this one to 10 by 10, let's see what will happen. So as you can see, along the y-axis, you have 440 pixels, and along the x-axis, you have 387 pixels. Let me change it to 20 by 20. Please, have you seen the changes?
Yes, I'm seeing it.
Yeah, so that right now, 2 pixels are going to be merged as 1 pixel. It's going to be resample as 1 pixel. So the buffer size will never change. It will be the same image, but the resolution of the image is what is going to change for that particular area.
All right. So then it means the higher resolution is going to give you some kind of higher accuracy if there is an accuracy check in there.
Yes, yes, yes. So yes, please. Okay, so this is, if no other question, this is where you end the course for the introduction to the cloud computing and for the introduction to Python and cloud computing. And this is just one of the first training that you are going to have. There's going to be a series of trainings whereby you're also going to do much more complicated things. We haven't even done machine learning, classification of items at this stage. And we are going to do a lot of things for this particular, forgetting the name, but for this particular chapter, or for this particular unit. So for the working group 7, there are a lot of things that we plan to do for us to be able to actually utilize all these free resources available for us to do. Not only are you going to handle the Jupyter Notebook, we also move to JE, and we are going to do a lot of training alongside the line. We actually appreciate all of you for being with us for the past, from last week up to this week, and we thank you all. So please, if you have any question, just reach out to that John, Jed, or I, then we'll be happy to support you. So thank you very much. At this point, I'll hand it over to Michael for him to end us.
Yes, thank you very much. We have to give you Dr. Abuama. I think it's this one is actually the application of the Python that we have been learning for the past week. I'm sure the kitchen is getting hot for a lot of people. But I think we need to even know more, because even some of us who have the Python background, at a point in time, I was lost, because now I have to now get the basics of the digital earth as well. So it means we need more to learn. We need to practice more, and then we need to read more about the digital earth so that applying the Python in it becomes easier. Otherwise, your Python becomes just raw Python, and you can't really use it in the digital earth platform. So yes, I think, yeah, tomorrow is also going to be like the last day for this master class, and I will be very happy to get all of us here. Let's get the others who started with us to join so that we can close the session. Well, I think we will not end it like that after tomorrow. We would have to hold some session later, whether it's in person or online. We still need to hold some session to then take some mini projects and then practice, so that we can get people to really be familiar with the digital earth. What's your take on it, Bowen?
Yes, Michael, that would actually be a great idea. And I think after this session, we can plan towards that on how we can get those mini projects and even hackathon or some exercise there for people to continue practicing. And if possible, if you can get sponsorship for a face-to-face, that would be very great.
Great. So yes, I mentioned a hackathon the last time, and then it should come with some competition. And that can be like a mini seminar for your working group, which we can plan it for maybe either the first quarter of next year. You can work towards getting sponsorship, and then we see how it goes, because a lot of people will be really interested, and you can really do this with 1 or 2 other working groups, because everything you are doing, I think it supports the other working groups as well. Then you can work towards the hackathon. Those who are learning it now, almost everybody here can come and compete. And then we see whether they are able to win some prizes. And probably some organizations will also be there to recruit some of the best as well. So let's see how we can package it, get some very good topics out of it, maybe in conjunction with some of the working groups. And then we can create a mini seminar, whether it is 100 people or 150 people for that. And then we'll work towards getting sponsorship. And then you can work towards that one, and then we'll see how it goes.
Okay, Michael.
Yes. So thank you all for joining our session today. Let's see you tomorrow, and then we can close this particular masterclass whilst we wait for what will be announced next by the CPD committee. Have a great evening.